Hi, I'm Dawn Ashby. I work in the NextOcean project as the communications lead. And I'd just really like to welcome you to our second webinar of the series. This is about the NextOcean Services, and it's subtitled From Market Survey to the Initial Design of Commercial Earth Observation Services. So here's the speakers we've got today. We're really pleased to have Hervé Caumount. He's a senior architect who's managing Terradue's corporate programs of business development, product and line innovation solutions and marketing. He's leading the NextOcean Consortium activities related to adaptation and customization of services for cloud computing. Pedro Ribero, he's an oceanographer and downstream service specialist from Plus Atlantic, and he's supporting the development of characterization of fishing areas and the fish provenance and ecolabelling services that we do in NextOcean. Andre, he's from PML, he's a marine earth observation scientist, and he's heading the development of the fisheries monitoring surveillance and the monitoring of aquaculture structure services that are being delivered by PML in Plymouth. And Marion Sutton from CLS is an oceanographer and project manager in the satellite downstream applications team, and she's in charge of the site risk assessment and fish farms impact services for NextOcean. So I'll just hand you over to Hervé. He's going to tell you about the NextOcean services. Thanks ever so much.
Thank you, Dawn. Yes, so I will introduce the session. We have a few slides to recap on the approach in NextOcean for developing and deploying services for fishing and aquaculture. And we have this lineage of an initial study, market survey, which led us within a few months of the start of our activities in NextOcean to the initial design of commercial EO services. And that's what my colleagues will present right after me. So our team mission within NextOcean is to operate innovative online services for fishing and aquaculture with the technological advances of tapping into cloud compute resources and, of course, making use of Earth observation data resources, and to connect to a common service delivery platform, the so-called NextOcean online store. So the focus today is on the services themselves. And we have also the mission to implement guidelines for service providers to perform their service integration and deployment as cloud appliances, and to operate their service as a data delivery feed that will serve customers of the NextOcean online store. So from the market survey, we have done with other colleagues, other teams in NextOcean, competition analysis, where skills and technological know-how in using Earth observations have been assessed for the monitoring of fishing and aquaculture activities, which led to the definition of user scenario performances. So this was an approach based on the triple bottom line by Ellington, and which encompasses social, environmental, and economic perspectives of sustainable fishing and aquaculture. And this then supported the organization of co-creation workshops aimed at defining business cases. So these were our starting points for selecting the initial services, because the set of services we are presenting today are really the kickstarters, the initial services for NextOcean. So out of these business cases, we have a selection of 6 services, three of them being more focused on fishing. So the characterization of fishing areas that is led by a collaboration between Deimos and IPMA, the fish provenance and eco-labeling, and the fisheries monitoring and surveillance, which is led by PML. And then we have another series of 3 services more focused on aquaculture, the monitoring of aquaculture structures, also led by PML, and then fish farm impacts and site risk assessment, led by CLS. On the services integration side, Terradue, my company, is providing access to the Ellipse solutions, which is a set of cloud compute services providing interoperability for EU-based products, implementing open geospatial consortium standards, scalable cloud computing technology, and portability, which means across cloud vendors. So we have freedom to move where the best offer lives for us. And so that's no cloud vendor looking, thanks to this approach supported by ELIP. And now to conclude on this introduction, I just wanted to highlight the early stage work we have done on preparing the services and the data products the services are delivering for their presentation on the NextOcean online store. So each of them have been through a thorough process of defining the product unique identification for the purchase orders that are being managed on the online store, and for API calls for the data feeds connectivity to the online store. Of course, the application domains where recommended and typical usages are provided for each data product. The product specifications, that's a full range of technical properties of the products, which are very important for end users when they are considering ingesting those products inside their own systems for exploitation, as well as the data quality. And then we have a few also activities on delivering preview and understanding of the technical details for those products. So that's for supporting demos and testing and exploitation. To conclude on this product description, we have also started working on the constraints, the legal constraints, which are very important when we operate on an online store, providing customer purchases, support for purchases of commercial services. So there are the applicable licenses, the applicable usage and security constraints in terms of anything like limitations on use, on distribution, on reproduction, or even in some cases on security constraints with the use of the products. So now I will leave the floor to my colleagues. They will go through the 6 initial services in NextOcean, starting with Pedro for Deimos. And Pedro, the floor is yours.
Okay, thank you very much. A very good morning to everyone. Thanks for having me. So I'll start describing the services that are being developed both by Deimos and IPMA. So if you can move to the next one. So yes, exactly. The first service that I'm going to describe is the characterization of fishing areas. And the idea there is to generate fishing bulletins indicating potential favorable productive areas for fishing tuna in the North Atlantic, which is the first fishery we are addressing in this application. So of course, the typical applications there, we can see applications for the fishing industry to improve their efficiency. So spending less fuel and emitting less carbon to provide the same products. But we can also see applications for other users. For instance, environmental researchers that are interested in understand how the fisheries are taking advantage of these productive areas. So, like I said, this is currently available for the Portuguese waters, but it's on the North Atlantic, but it's limited to the tuna fishery, but it can also be extended for other areas depending on data to validate the services. And there's a lot of data being deployed here, mostly the maps that are being produced using data from Copernicus Marine Service, but we have to do the validation of this with the actual catches and the actual fishing activity that we retrieve from IPMA and DGPM in other projects. So that's the kind of validation that we're performing. If you can proceed for the next one, yes. So yes, if you can go clicking now, there's some animation. I'm trying to show here, we start to produce these maps by separating the coastal zone from the oceanic zone. So this is something that we're doing because we have different algorithms for the coastal and the ocean and the offshore zone. So we have this coastal stretch of just 200 kilometers. Within this area, we are looking for coastal fronts, for ocean fronts. So in this case, thermal fronts on face-to-face temperature. After we find these areas, we have strong changes on strong gradients on temperature. We can consider them to be thermal fronts, and then we create a buffer area of around 20 kilometers around these fronts. And then using chlorophyll data, we select just the clear water. Since tuna is a visual predator, we want to have those areas as potential fishing areas. And the result is these maps, as you can see here. The first one is with colors, different colors for different days, where you can see the ocean fronts. In the second map, you can already see the potential fishing areas. So these fronts, together with the 20 kilometers buffer zone to the clear side, that's where we expect to have better fishing. Again, this is also being presented for multiple days, so you can see a little bit the progression. Second service that we're developing, this one only by Deimos, is looking at the fish provenance and Ecolabelling. So we're trying to develop a tool that monitors fishing activities and then can be used by certification authorities, regulators, and all sorts of users that are interested to have information on these fishing activities. So we can see applications for regulations on fisheries, of course, but we can also see application for environmental monitor of marine protected areas. We can see, and we're also quite exciting with the certification market. So we want to introduce this information in the supply chain of fishing. And again, this is currently available only for Portuguese waters, but it's also possible of being extended. Demanding, of course, more data for validation. And in this case, the data that is based in the production, that is being used for the production of this data, of this information, is AES data retrieved from commercial providers. So next one, just so I can show a little bit of an example how this works. We get these AES points, and which are, of course, connected to a specific fishing vessel. We can then separate the different fishing trips by understanding when they're leaving and when they're returning to the port. And we try to identify within those points, AES points, which of those are corresponding to times in which the vessel is fishing and times in which the vessel is just traveling. With this information, we can then try to look at the specific areas. What I'm showing here is a marine protected area on the Azores archipelago. And as you can see from the red dots there, you can see that some of those fishing trips actually had fishing activity within this marine protected area. So of course, this is just a first layer of information. It has to be analyzed to understand what are the implications of this fishing if that is not allowed in that area or different regulations may apply. So this is just an information service that can be used for different ends for the users. Next one. So this information is also aggregated for all different fishing vessels or for a specific fishing fleet, and it can also be filtered for different seasons or months. And then you can have this aggregated maps of fishing activity, where we can see, this is of course only the red dots coming from the fishing trip, so we can see where the fishing activity is being performed within an area of interest. And this is, we also have a possibility of adjust this temporal and spatial resolution depending on the application and the availability of data. So what I'm showing here is just a seasonality analysis, looking again at the Azores archipelago, but we can see, next one, please, that we can also convert this information into time series to understand how the fishery activity is varying along the seasons along the year. So this is just one application, but we can see different uses for this information as I explained before. So we expect to develop this within NextOcean co-design activities to further improve the service.
Thank you very much, Pedro. So we'll take questions at the end of the session. So now we move on with our partner PML and André, which we present the next two services. André.
Good morning, everyone. I would like to present two services developed by Plymouth Marine Laboratory. And the first one is Fisheries Monitoring and Surveillance Service, FMS service, which was designed to monitor illegal fishing activities in the area. Originally, it was in West Africa, Ghana. And usually for monitoring fishing fleet, well, many organizations use automatic identification system AIS data, which shows the location of each vessel, identification number, destination port, size of vessel, and what kind of vessel it is. And if some vessels are involved in illegal fishing activities, then they try to hide their identity by switching off a system installed aboard of vessel or spoofing this system, and then this vessel become invisible for monitoring. And in this service that we developed, we use satellite Earth observation data to look at the vessels in the region of interest. Any vessels can be detected from space, the vessels that use AIS and the vessels that spoof AIS system. We use Sentinel-1 synthetic aperture radar data to detect vessels in the region, and we identify this vessel's location, dimensions, and then we compare this data to AIS data to identify vessels that switch off or spoof AIS system and can be potentially involved in illegal fishing activity. So this system provides maps of vessels in the region, which shows location of vessels that use AIS and vessels that do not use AIS. Such vessels are shown in red in the middle of the slide. We also show tracks of vessels provided by AIS, dimension and identification number of this vessel in our service. And this service provides latency of about up to 12 hours when we use Sentinel-1 SAR freely available data provided by the European Space Agency. But end users can reduce this time by using commercial satellite sensors, but in this case, the service will be more expensive. The next service that we developed is called Monitoring of Aquaculture Structures, MAS service, which maps aquacultures of different types like fish cages, shellfish farms, or floating houses and jetties used to service aquaculture sites. Again, we use remote sensing data to map these objects, and the service provides quite accurate estimates of locations of fish cages of size up to several meters. And this map shows the location of these cages at different moment of time, so that we can produce time series of these maps that will show you how aquaculture structures have been transported to different locations, or new structures were deployed in the area. This slide shows an example of aquaculture map in the Malampaya Sound, Philippines, Palawan, obtained in 2016, shown in red, and 3 years after, in 2019, and these structures are shown in yellow. So we can see how much changes this area went through in these 3 years, and how aquaculture has been developed over these 3 years. Currently, this service covers Palawan, Philippines region, but can be extended to other coastal areas covered by a Sentinel-1 SAR sensor. We also apply the service to map salmon cages in the north of Scotland. This illustration is given on the right, and these maps were validated by using Google Earth high-resolution images. Thank you.
Thank you, André. And we conclude this series of presentation on services with Marion from CLS.
Good morning, everyone. So I will present you now the services that will be developed by CLS in the frame of NextOcean. So the two services will be addressing more aquaculture and fish farms industries. So the first one, the site risk assessment service, it's addressing all the issues of pollution that can impact on the sites, on the aquaculture sites. So the idea is to provide the fish farmers the information on the environmental monitoring on their sites, and to provide them with the information of potential pollution that can have an impact on their sites. So today we see different types of pollution. First one would be the oil spills as marine pollution. So oil spills from vessels passing at the vicinity of the farms. For this oil spill monitoring, we will base the service on the use of Sentinel-1 data, of synthetic aperture radar data, on which we can detect the pollution. With that, we can also do some prediction of the trajectory of this oil spill to see if it will impact the sites. And we want also to work on other types of pollution that we can refer to as pollution, and it can be, for example, harmful algae bloom, so bloom of algae, or marine heat waves, so extreme events that can have an impact and can have a pollution impact on the sites. For this last two environmental extreme events, can you come back a little bit, please? Thank you. We will base our service on the environmental data that we can find from the Copernicus services, and to elaborate some early warning on the environmental data that can help us to define the favorable environmental context of the occurring of these extreme events. So for the site risk assessments, we have two types of application that can be derived from this. First one is an early warning in real time. So we want to provide to the fish farmers an early warning system to help them anticipate the arrival of pollution and to prepare some mitigation plan. So it will be in real time the detection of the oil spills on the synthetic aperture radar Sentinel-1 data. With this, we can actually do that with a revisit time of 2 days over Europe and the Mediterranean Sea using the Sentinel-1 data. This revisit period can be increased if we go and process commercial missions using SAR data. So first one will be, as I said, an early warning in real time, and the other sub-service would be also to provide reanalysis of particular events. So it could be on marine oil spill pollution, but also on extreme events. So providing some information on a particular event to claim for insurance, for example, or to help to understand a particular event. You can go to the next slide, please. Just an example of the products that will be delivered in this service. So you can see on the left, the first image on the left represents a SAR image processed, on which you can see the result of the detection of an oil spill with the brown area. And you also have all the vessels that have been detected in the vicinity of this pollution, and the service will provide some information on the potential polluter that was at the origin of this pollution. On the right side, you also have some environmental data showing harmful algae bloom on the top right, and on the bottom right you also have another detection of oil spill showing in red the results of an oil spill that was detected from illegal venting. So the second service that we will be focusing on and develop in the frame of NextOcean will be again related to pollution, but this time it will focus on pollution that are coming from the fish farms. So while we are in the first service, we are really looking at environmental monitoring and helping the farmers to monitor their environment and to prevent their production from pollution. From being polluted. In these fish farm impacts, we want to provide some services to help the fish farms to prevent them from polluting their environment. So it will be mainly based on or focusing on two applications. First one will be to detect the pollution as for oil spill. So coming from the grease of the fish nourishments that are deployed on the fish farms, and the second one will be focusing on the farming materials, because we know that now some of the aquaculture sites are installed in very exposed area, exposed to strong currents and to bad weather, and there is a risk of losing some fishing materials and to adding some plastic pollution to the ocean. So the idea of this service is to give some tools to the fish farmers to prepare and to prevent these pollution, and helping them to prepare the operation for fish nourishment, for operation and maintenance on the cage, or to do some mitigation actions on this potential pollution. So if you go to the next slide. These are an example of the products that we will be able to produce. So on the top right, again, you see that we are able to detect the pollution coming from a fish farm, probably after some nourishment or some grease added to the water. And on the two other images, you can see a result of drift model coming from some aquaculture sites or from on tropical hills area, where using the currents and dispersion by the current and the wind, you can actually see the trajectory of some particles coming from the site and dispersing and propagating into the vicinity of the cage. And yes.
Thank you very much, Marion. Well, this concludes this presentation of the 6 initial services in NextOcean. And I'm now going to summarize very quickly before we enter the question and answers on the benefits from using Earth observation data in these services. So you saw that from the presenters that we are relying on both satellite onboard sensor technologies and as well as in situ sensor technologies, which all together they empower the NextOcean service providers with features for their products, such as low-cost repeatable acquisitions. So this is typically a property provided by all satellites, especially satellites constellations, which are more and more, which are growing in the industry, so they can deliver higher revisit times. Vision through clouds and all-weather acquisitions, typically provided by synthetic aperture radar satellites, as well as a global coverage, global acquisitions, including a high resolution or very high resolution, spatial resolution acquisitions, with multispectral acquisitions in different specters of the optical range, and then also with high visit frequency. We are also relying on technologies for ship identification, ship location, ship bearing and velocity, which are AIS, but also a vessel monitoring system in some cases. And typically AIS can be both technology deployed initially, historically, as in situ with radio connectivity, radio networks along the coast, but more and more now also operated as satellite-based AIS technology, which again here provides global mapping of maritime data. There are also elaborated products, typically the Copernicus Services products, which are scientifically assessed ocean data, and which are generally also providing a global coverage. So all this is empowering the NextOcean Services for answering the market needs. Then technically, to make this happen, we are relying on a set of solutions for the systematic use of Earth observation data so that we can address customer needs. First thing to notice is the option, the benefit that we have in the consortium to get access to the Copernicus data warehouse, where we will get very high resolution and data from all the third-party missions which are partnering with Copernicus, and that we'll use for validation. This was mentioned previously, and also will be used to validate the evolutions of the service to serve customers who will request advanced properties for the data services, like the revisit time or like the spatial resolution. Then we have a number of partners, tools. So I've mentioned my company Terradue, also Deimos, and of course each partner which are developing the services, tools and solutions for the exploitation of this EO data, and especially for the cataloging and the online access to EO data, so that we can implement and deliver data feeds to serve the customer needs. And just to notice that as part of the NextOcean Consortium, we are benefiting from a brand new service implemented based on a new standard from the Open Geospatial Consortium. So that's the best practice for Earth observation application packages released earlier in January. And that's a standards and technology innovation that is supported by Terradue through the Ellipse solutions, made available to the NextOcean partners for their integration of their services. So to conclude, this is the overview of the operations that are foreseen in NextOcean, so to address customer needs. So you have on the right side of the slide the customer communities, which will be users of the NextOcean online store. And they will access via interoperability protocols implemented by the online store to a cloud deployments of the NextOcean services. I've mentioned the portability of the implementations. So the service providers will select the cloud provider they want to rely on for the operations. And here we have a few examples of the cloud providers which are connected to the Ellipse solutions via APIs. And so on the top of the diagram, you see the work of the service providers integrating their application as a cloud appliance that will deliver a so-called application package, what the best practice from OGC is standardizing, so that this can be deployed on demand to a selected cloud provider. And again, through interoperability protocols, when running on a selected cloud, these services will access remotely to data sources, selected data sources, which are hosted on a cloud storage. We can provision data buckets on demand, so to create our own repositories which are needed by a service, or we'll access existing repositories operated by the different main or major service providers in EO data. To mention on the right side of the slide, the online store is the front end for the customers, but we have also this provider side, the marketplace, where the service providers are registering their services, and all the initial work I have introduced is important in this matter, because this is how a service provider will make their service visible, and how they will control the way their services is presented to customers. So that's it for me, and we are looking forward hearing from you. So that's the question and answer session, and I think it will be moderated by our colleague Nuno Grosso.
Thank you very much, Hervé. And thank you to all presenters for their really nice presentations of the different services within NextOcean. We are quite balanced in terms of questions to different presenters. And you were kind enough to put some questions already in the chat. The idea is that if you do have some additional questions, please put them in the chat so that I can go through them. And hopefully we have time to cover them all. So the first one is to Pedro Ribero from Ecolabelling, to understand did you overlay the IES map with the tuna likelihood map? So was there a match between the areas identified in that thermal front detection product with the fishing footprint that you presented earlier?
Okay, thank you, Anton, for the question. Quite interesting, actually. Of course, that's something that we are considering to explore. But I have to say that while we are already trying to make some validation of both products using e-log, the catches data from e-log books, so something that's, and also the trip data, so the positions and the time of the fishing activities, we're using all this data, which is quite sensible, just for validation. But of course, comparing the outputs of both products should be quite interesting. First, just to characterize, if you, for instance, take one of those fishing footprints results and try to understand what in these areas where the activity was happening, what kind of environmental conditions were there. So you can, you should be able to overlay that and characterize these fishing areas. And again, then also to compare what we understand are potential more productive areas, if they are actually being used by fishers in these fishing footprint maps. So the intention is that the user can do this kind of analysis by himself, because those results shall be presented in a web-based GL portal that will allow the overlay of this different information. So this is the sort of analysis that we expect the users that can be allowed to do by themselves. So the idea here is to keep it very open, very flexible, to understand each different use case. And if we need to produce additional information, we can do it. But I guess for just this that you referenced in the question, you could already do it by using the GL portal and overlaying two different results from the same area, same period. You could already see that.
Thanks, Pedro. I hope that answer was satisfactory for Anton.
Can I speak?
Of course, Anton, go ahead.
Yeah, so no, thanks everybody first for the presentations and also for making this seminar a reality today. Sorry. No, some of my questions are basically just to have a bit more discussion on the presentation. So for Pedro, I think you need maybe to find a connection to more ecosystem modelers that need the type of data you have, and maybe they also have more ideas for you, maybe to bring this into a more ecosystem type analysis. I think for fisheries, it is quite far away from how, and I'm not a research organization, I feel. So I just give you some comments on the top of my head that are maybe a bit far off. So for a fisheries organization, I think you are presenting very nice results and information, but for the AIS data, I think a lot of people already have them and know how to analyze them. So, but the link with more ecosystem modelers, so more the research-oriented people in the fisheries community, they should be interested in having this as a service rather than as their own data set. So, so for me, the next phase would maybe try to make a connection to ecosystem modelers.
Thanks, Anton. This is for sure noted as a good suggestion. Yes, this is a first release, so we are talking about the minimum, just the first release of the projects, but we expect to have a lot of evolution during NextOcean. And for sure, we need to further develop this. We have this first approach for the potential fishing areas, which is, of course, coming from some research that was performed previously by IPMA. But we want to extend this to other fisheries, other species, and we know that this is quite specific and it will need a lot of input from these ecosystem modelers. So for sure, we want to connect them. I think it's a two-way connection. We can provide some readily available information. Sometimes the information it's out there, but it's not so easy to get to. So we are also taking care of this implementation so that we can have this information readily available. But of course, we also want to understand what other kind of information we could introduce in the project.
Thanks, Pedro. So we have quite a few questions to cover. So would like to have some, please try to be as concise as possible in your questions and answers. Also from Anton and now for Andre. The question is, do you also extract any features? So number of cages, estimated size covered by different identified objects. So is that something that currently your monitoring product does?
The answer is yes. We estimate for each cage that we detected, we estimate length and width. We approximate its shape as a rectangle, so we'll estimate the size of each fish cage, and also from Sentinel-2 MSI sensor, as we know already where the fish cage is, we can measure spectral properties of this object that may help in further classification of detected objects. Just to, for example, say if the fish cage is actively used or closed or in any other condition.
And you do that with SAR data, sorry?
We combine SAR data and spectral data. From SAR data, we estimate dimensions of the object, and we can use spectral data to measure spectral properties of this object.
I'd like to see an example of it, if you have one. Because
Right.
it's not so easy to see if a cage is active or not.
All right. Thank you.
Thanks, Andre. Thanks, Anton, for those questions. We go now to the presentation from Marion, which now has quite a few questions there. The first is from Alexander Knight. The use of Copernicus is often criticized for having a low resolution when it comes to the value of monitoring in aquaculture. How do you deal with this?
Okay, so I think this was referring to the first service. So what we do in the frame of NextOcean, we have a co-design team also, and we are working with the users and potential users. And this is exactly the type of discussion that we would like to have with them. And in particular, we are discussing with partners who use in situ data for environmental on sites, on specific sites. And what we would like to provide them is to add the aerial and the forecast dimension to this in situ data. And what we will be doing during the project is also to see if the data that we are providing and we are using from Copernicus provides enough data and enough accuracy when they combine this with their in situ data, and if it's enough to help them to monitor the favorable condition of the occurrence of extreme events such as HAB or marine heat waves. So I think this is something that we will be able to answer during the frame of the project, and we hope that with the satellite data and the model data that we can find from the Copernicus systems, there are some data that we can use to anticipate and to monitor correctly the environment. I hope that answers your question.
Yes, thank you.
Marianne, next question from Marianne.
Okay.
Is from Anton. So how can you trace back spilled or harmful algal blooms to the source of pollution, for instance, a vessel or a river discharge? Or can you only identify potential sources?
What we usually do, so this is a service that we actually provide to the European Maritime and Safety Agency, so for the detection of oil spills in the European waters and the identification of the polluters. So from your detection on the SAR image and using some drift modeling and also correlating with the IAS data that you have in the vicinity, we do some cross correlation, and we target a certain number of vessels that are probably in cause or causing the pollution. So I suppose it's more like identifying potential sources, but with a certain level of confidence. And in some cases, we are really able to point on the actual polluter. For HAB, so HAB, it's a bit different because we actually don't detect the HAB today. So it's a complicated task, and we have said that during the frame of the project, it was difficult to provide a generic service for detecting HAB. So that's why we are more providing environmental monitoring that will help to monitor the favorable condition of occurrence of HAB occurrence or marine heat wave occurrence. So we don't go that far of the identifying the potential sources of the HAB. Yeah. Okay.
Okay. Thank you.
Thanks, Marianne, for that answer. Third question for Marianne from Philippus Paparizou. I'm sorry if I mispronounced it. Most probably I did. When you mention nourishment influence from farms, what exactly do you measure and how?
Okay. I just want to add a last point on the previous question about the river discharge. And this is applicable for both services, actually. With the drift model, we intend to do some drift simulation coming from the main river mouth, and this will help. This can help to anticipate, for example, if there are some plastic coming from a river output, or using a particle model to see if the site is too close to a river mouth, and if in some conditions some pollution from the river can impact on the site. So this is something that would be feasible to do as well. Sorry, back to the other question on the nourishment. So what we measure or what we observe, again, it's on the SAR images from Sentinel-1 data. And it's from the SAR sensor, it looks like as any other like oil pollution. So you really see the difference in the sea surface roughness. And so what we see from the farms with this technology is really some maybe some grease or some oil coming from the farms. Although what we don't know, and what this is something that we also want to discuss during the frame of the project by discussing with users, is if this information is useful for fish farmers. Because this is something that we can do, but is this something that actually fish farms wants to know? Yeah.
Yeah, thank you very much. Am I allowed to intervene, to ask?
Yes. Well,
yes. Yes, you are.
Thank you very much. I think, I don't know if it's how possible it is, but it would be more interesting for a farm and for the regulators if we could possibly measure the nutrient load in terms of nitrogen, phosphorus, or any organic carbon that is released in the cage, well, around the cages after feeding or during the overall operation. There might be some distributions. For example, if you measure right after feeding for the next half hour, you might see some increased levels of nitrogen and phosphorus, but maybe 6 hours later that will have disappeared, and definitely it will have different distribution in the water column. These are information. These are data that a fish farmer and a regulator would like to know. Is there any way of getting down to this level?
I don't know, but this is something I think, for again, the objective and the way we work in the NextOcean team is really to work with the users. And so we have a process. So what we are presenting today are the minimum viable product that we have come out with, knowing our own set of services and usual communities of users, and trying to think, okay, this can be of use for fish farms or aquaculture or fisheries. But now we need to have this discussion, and I think this is a long process that we will have during the frame of the project, and to see, like, to compare the technology that we can do and the real needs, and to refine all the services along the project to be sure that this is something actually usable and feasible for the users.
Thank you very much.
We welcome you. Sorry, we welcome you in the next co-design workshops, and your input would be valuable there to understand a bit what your user requirements are for this type of products, and what you can bring to this discussion, and how can you drive the evolution of the services being developed by CLS and NextOcean. So be in the lookout. Maybe Peter has some info on the co-design events that will take place in the next month, and you can take part of those. Peter, do you want to complement there?
Yeah, I think the next co-design workshop is scheduled for September this year. So yeah, we will take note of end users who are interested in being part of that process. So yeah, very happy if Philippos or Alexandra want to be involved in that. So yeah, we have yeah, you could put in the chat now, or you can respond when we give an invitation to that later, nearer the time.
Thanks, Peter. Thanks for that. So last question that I have, I think, yeah, last question I have from in the chat is again from Alexandra, with to Marian. Who are the core users of the fish farm impact? Do you know how this service adds to the current monitoring reporting regime, so compulsory for the companies?
Well, I think it would be a similar answer in the way that so we have this technology and this service that we can build, and now we also know that there are some regulation that's is compulsory for companies to monitor their environment, and so this is something that we want to add as a service to to the fish farms. So on the core users, again, in the consortium, we also have a team working on this on the business and the marketing and on who these services should be directed to. So this is the business team working with us, and they should help us to define the users and to define the end users of each of the services. But yes, again, I think it would be very interesting to continue the discussion and maybe not wait for the co-design. I think this is something that we can do before, because September is quite a long time, and in the frame of the project, it's of course it's possible to discuss before.
Indeed, you're right. So September is a long time from now, and people are engaged and interested. We could try to advance that. Alexandra, any other comment and any other follow up on that, on the question, on the answer from Mariam?
Yeah, well, thank you very much. I think it's very dependent, as you say, who the end users will be and how to define the services in connection to what is already there and what is the maybe the future needs as well, because there are in the development, and now with the new guidelines for EU aquaculture, there might be some new demands for documentation from the farmers. But it's always important, I think, to have a kind of a balance, that we don't impose new services to the companies, because they are very reluctant to have to invest even more in certain issues. So it has to, I think, also provide a benefit for their for their management or operational functions, if they will invest in that. Thank you.
And I think that's just answering your last comment. That's why we initially thought on the fish farm impacts on monitoring of the oil coming from the farms, but after several discussions, we realized that it was adding more regulation to the fish farm. So maybe this is not the good approach, and this is what we want to adjust during the project.
Okay, that's maybe so. Maybe a good point that Mariam made is to try to understand, to have a scope in between the co-design workshops that we have for this type of discussions, and now the different users that are now engaged via the webinars or the previous workshops that we did can further engage with the project. So that's something to see. I don't know if Peter, Hervé, do you have a way to move forward in between these co-design workshops?
Yes, I think you're quite right. September is a long time to wait if there are potential applications that we should explore sooner. So yeah, I'd suggest that, for instance, if Marian is the service provider related to that query from Alexandra or Philippos, that they organize a one-to-one interview and feed that information into the project, then we will incorporate that as a potential requirement and weigh that up against the other suggestions that come out of the co-design workshops. That'd be excellent.
Yes, that would be perfect. Well, if Alexandra and Philippos are okay and happy with that, it would be a pleasure to continue the discussion.
Okay, perfect. Now we reached the 1 CT 12 PT good time, so we need to wrap up. I'll pass it over to Dawn to wrap up, or is it to Hervé?
I think there's one more question, isn't there?
Oh, is there? There is. I'm very sorry, Alexandra. There was an additional question from you that I missed. Service additionality plus cost plus user friendliness are key factors for private companies interested in services. Will this be evaluated by the project? So this is a more generic question to the project of how we will evaluate these different characteristics of the services. How will they factor into the co-design process, I would say. Maybe Peter again. Is it like?
Yeah, I don't know if there's Luis on the call because he's leading the business development part of NextOcean, but from my perspective, leading the co-design activities, now that we have a better idea about how the services are developing, we will keep asking questions of potential users about their willingness to pay, you know, how much people are prepared to pay for the services, how unique they are, you know, are they improved on what you can get elsewhere, are they friendly enough? We're trying to build in some easy web portals for people to access and visualize the data once they purchase them. So yeah, we as a project, we will certainly be approaching potential customers and discussing with them their requirements and their the factors that involved in their decision making.
What I can add is that the factors that you are mentioning, they are part of our value proposition. So as a consequence of that, we need to measure them. And regarding the specific issue of cost, we already asked the different service providers to provide the prices for the services, for the more standardized ones and for the more customized ones. We also asked potential users to provide some price guidelines, and now we are waiting for feedback. So the answer is yes.
Oh, brilliant. I think we've come to the end of the questions. I'd just like to say thank you everyone for participating and for your interesting questions and providing us with food for thought on how we can develop our services. We'd like to keep you informed about future NextOcean events, and if you'd like to follow us on Twitter and LinkedIn, we'll keep frequent updates on the project. So we hope to see you at the next webinar, which should be on the co-design process. And thanks again, everybody. Bye.